machine learning, distributed computing, Java microprocessor. So without taking much time, I'll hand it over to you, sir, and you can start with the session. Thank you.
Thank you, ma'am, for the brief introduction. And first of all, a very warm good evening to one and all. Yes, I'm expecting response from my students. Good evening, everyone.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening. So nice to see you all here. And if you know the topic already, right? It's importance of EDA, exploratory data analysis in machine learning, basically, right? And if you have already done this course, or maybe you are enrolled in Aegis, so you might have done this in the first semester only, and into machine learning subject only, right? But especially for those people, those who are like willing to enter into machine learning or data science domain, and they are not really like comfortable way to start from, or maybe they are not sure whether to go for this domain or not. And one of the biggest reason is there are jargons, or you can say a lot of complicated videos on YouTube, and even on good sites as well, where if you see few of the videos, people get stuck. They are like, this data science or machine learning is not my domain, right? So I will make sure that you start loving machine learning or data science, and the terminologies or the jargon words that we use into EDA, I will try to like simplify, and I will try to explain you in simple terms. All right. So let me share my screen, and please do let me know, is it visible to all of you or not? Is it visible? Please, someone confirm. Is my screen visible?
Yes,
right.
sir. Visible.
Right. Thank you. So, as name suggests, it's EDA, exploratory data analysis. So it will be what we will be exploring the data that we have. Okay, and these are the terms that that I'll be covering up, like objectives and steps of EDA, types of data, summary statistics, comparing features, and using some of the libraries like pandas, numpy, and like visualization tools like matplotlib and seaborn as well. So I will start with the question: why is ML AI booming right now? I want to answer from my students. This term, if you say machine learning, was coined back in 1959, right? 1959. It's been around more than now 60, 70 years, but still it was not much used, right? And you can see since last 2 decades only, and especially in this decade, we have this ML AI coming up, and it's booming right now. So my simple question is, all the algorithms that you see, or everything like mathematical terminologies you see into ML and AI, they all are in like they were invented back in 1950s and 1940s only. So people name this that we will be someday we will be having robot which will behave like human being, and there will be like a lot of things that will be doing through that robot, will be like having automated things. They name it, but even then they were not in a position to implement those things. So I'm coming back to my question. Anyone from the audience, why ML AI data science booming right now?
So that's because right now, earlier we did not have a lot of data which is generated in today's world.
Exactly. Yeah.
Earlier, the data meant only the Excel sheets, the structured data to us, while machine learning helps us to deal with unstructured, semi-structured, and structured data. And that's why. And
Very
now
nice.
we have that amount of data and the storage capacity for it.
Exactly, right. So right now, everything is digitized, right? So we have everything in terms of online. Even now we are booking tickets, right? Just imagine our childhood. At that time, we don't have, like when we go to the counters, we used to have a ticket on papers, right? So the record was not maintained anywhere, even though if the record was maintained on paper basically. So converting that complete paper into Excel sheets was not an easy task at all. So, Martha Samuel, who invented like machine learning back in 1959, he knew about these terms, but at the same time, he knew that if you want to implement or if you want to get, machine learning model, which should have very nice accuracy, for that, we need to have very, very large data set. And that is the reason from 1959 to like even till you can say 2000, it was not much booming. It was like there, but it was not much used by anyone. But now you can see since last 2 decades, and especially into this pandemic, everything is coming online, right? So now we have like data into like you can't even imagine in terms of memory, right? So each day it is being generated, and to that online things, we also have social media, right? We got Facebook, we got Insta, we got WhatsApp. So from these also, lot of data is being generated. And now it's like data is not only being generated, it is being now used for analysis and into machine learning and AI as well, right? So machine learning, if it is a, someone said this, so if it is a rocket, then your data is its fuel, right? So to launch a rocket, you can't launch it without the fuel, right? So that was the reason again, your ML was invented back in 1959, but it still wasn't used much. But as now we have data, that's the reason we are building very nice or very, you can say accurate machine learning systems and AI systems basically, right? So now, why do we require EDA process? Now coming to EDA process, exploratory data analysis. See, the data that you will be getting will be a raw data. When I say raw data, it is like the data that is, collected, but the data is not a clean data. There may be some missing values, right? There may be some features which are not really useful. So you will be getting the complete data set. Now, once you get a data set, you might have heard that, into machine learning, the steps, if you know, it's like you have to do pre-processing, then you have to select the algorithm, right? After collection of data. And then like you have to select the model, the algorithm, and you have to train the algorithm, and then you have to test it, and then you have to deploy it. Generally, we go with this, right? So where this EDA comes from? So this EDA process is something that you have even before pre-processing. Once you get the data, or as soon as you collect the data, you need to explore the data, right? And why the exploration is required? Let me just tell you. So based on the data that you have, you will be deciding or you will be predicting something, right? Now, just for example, I am running a bank, right? And like, for example, I have customers coming to my bank, and now I want to go with a new insurance policy, for example. I want to launch a new insurance policy. So as of now, all those customers, those who came to me and to whom I have shown the currently available loan policies, I will have that complete data set. Like what was the name of that person, what was the age of that person, or the customer that are coming to me, and then salary and all those parameters, and based on it, whether that person had taken the insurance policy or not. So that information that I have already. So while keeping the record, there is a possibility that I have some missing values. I was not able to get the salary of a person, so that data will be missing data, right? And apart from that as well, now, based on the parameters, let me just tell you how your machine learning exactly works, right? I'm going with the same example of insurance, like name, based on the name, based on the age, salary, and like all different factors, I am deciding whether the person is taking the insurance or not, right? So all these things, the parameters, are called as independent features. I'm using some, the terms that we use into machine learning. And whatever you have to predict finally, that thing is called as dependent feature. Is that clear? So all your columns in the data set that you will be having will be called as what? Features. And the parameter that you will be using will be called as independent. And finally, whatever you will be predicting, that will be called as what? A dependent feature. So we'll be having multiple X values and one Y value. Now just imagine if some data is missing from your data set and your system is considering that missing value to be 0. Like just for example, you have all the information in a row and age is missing. And if I am considering age to be 0 instead of missing, that will mislead us, right? Our date, the accuracy of our system will be hampered very badly. So, data cleaning is important. And even before that, you need to just explore the data. Even while selecting the algorithm, your algorithm will be selected based on how your data looks like and how your data is all about. Is that clear? So that is the reason. And EDA process comes into picture when you have very complex data set. Nowadays we don't have any like simple data set. We have very complicated data sets. So that is the reason doing EDA is something now mandatory. You have to do this, and based on EDA process, you will be performing all other steps of pre-processing as well. Is that clear? I hope you got the idea. Why do we require EDA? Now let's talk about EDA, like some of the things about EDA. Like it starts with what exploratory data analysis, and it's a process of critical, examining your, or you can say performing initial investigation on data to discover the patterns, to spot anomalies, to test hypotheses, or to check assumption with the help of summary statistics and graphical representation. So there are two important terms that are here that I have listed out as summary statistics and graphical representation. So I'll be going into the detail about that. So finally, what is the objectives of EDA? It will help us to identify the faulty points in the data. Also, it will help us to understand the relationship between the variables that we have. All right. So I'm just quickly going. So I told you guys, I won't be just giving you brief or abstract view of EDA. I will be telling you in detail or the jargons, the important terminologies of statistics and ML that we'll be using into EDA. I'll be explaining those in detail. At the end of this session, I want you to start loving machine learning and data science, basically. Right. So let's start with type of data. As we just discussed, the data is something really important for us. So when it comes to machine learning or AI, what type of data generally we have? The first type is numerical data, right? So, numerical data can be a continuous data or a discrete data, basically. So what is continuous data? I have taken the examples here as well. Like when you talk about continuous data, it has an infinite possible values, basically. Like, for example, price of a flat in Mumbai. If I have to define this will be what? This will be infinite values, right? At different places in Mumbai, I can have different prices, and that too, I can have values in fraction as well. So it's simply we would say it to be what? Infinite values. So if, whatever value you have, such values are called as what? Continuous values. One more example is how much rain fell during last 2 months. That will be in centimeters, right? But that value can be anything. So that's the reason we say it to be what? Infinite value. Okay. I mean, your continuous value can take infinite possible values. Similarly, we got something more to numeric, that is discrete data. So it is like integer based, often used to count the occurrence of some event. We like, discrete, right? Continuous is like you have continuous value. Whereas if you talk about discrete value, we generally have, integer value into it. Like, for example, how many people visited DMart in particular day? So it won't be like 5.5 people, right? It has to be a whole number. Like how many employees in my company are male? So all these things will be considered as what? Discrete data, basically. Now going ahead, the second type is what? Categorical data, which is very important. And we will quite often encounter this type of data into our data set. So it's like it's qualitative data that has no inherent mathematical meaning. All right. So data will be there, but as far as your mathematical equation or mathematical term is concerned, it won't have any meaning to it. Like, for example, gender. Gender will be either male or female. So you can't define male or female in terms of mathematics, right? You won't say male is always superior or female is not superior or female is superior, something like that. You won't be able to do that in terms of what maths. Like in maths, if you just compare 2 and 5, you will always say 2 is less than 5, right? But into categorical data, you won't be in a position to do that. All right. And categorical data you'll be having in terms of string values, right? Like gender, yes, no, or maybe state of residence, right? Where I'm residing, I'm in Maharashtra, for example. Someone is in Haryana, that doesn't matter, right? And that doesn't have any inherent mathematical meaning. All right. Now there can be a question in your mind, sir, when it is not mathematically inherent or if it has no value, will it have any significance with our result or with our y? It will have. It's not that like if it doesn't have mathematical meaning, it doesn't mean that it won't have any effect on my y, right? Now just imagine if I am calculating or I'm going with, shopping mall where majority of the thing is for ladies, for example. Okay, ladies clothing and all stuff, makeup stuff and all those things are there into that mall. So that time gender will be a major factor, right? So female gender will be more, and that will be more influencing your y basically. Is that clear? So categorical data, we won't simply delete it, right? It is important for us, and like we will convert using, there are techniques for it to convert into from string to, into numeric form, like 1 0 or 1 2 3 4 label encoding or one hot encoding, we generally use for that. Not going into the detail of how to convert it, but right now I'm just telling you about the type of data that we have. So I hope you got categorical, and there's something more to it, like ordinal data. Now ordinal data is like mixture of category and the numeric. It simply means it is like a categorical data, but it has some inherent mathematical meaning. Is that clear? Like the best example is rating of movie or rating of a session. You have been asked to rate the movie in terms of like excellent, it was excellent movie, or very good, good, average, or poor, or very bad, right? You got these terms now. When you say excellent, excellent will have some mathematical meaning, right? If I am just comparing in terms of 0 to 10, so your 9 and 10 will be something like excellent. So this is called as what? Ordinal data. Categorical data which has some inherent mathematical meaning. Is that clear? So I hope you got this concept. Now I just have something for guessing. How much fuel is remaining in the rocket? It has to be what? Continuous, right? Come on, guys. I am expecting answers from the participants. Right? How much fuel is remaining in the rocket? It has to be what? Continuous numeric. Yeah, good. Feedback of the session?
Ordinal.
Very nice. Color of our shirt? Can be anything, right? It has to be categorical. Yeah. Types of animals in the zoo? Again, category.
Categorical.
Money spent in Indian wedding? It's infinite, right? It's again continuous. Yeah, very nice. So continuous values we have. Okay. Now, I told you we will be performing EDA process based on summary statistics and visualization, right? So for visualization, we will be using some like libraries called Matplotlib and Seaborn. And for summary statistics, we will be using some formulas of statistics. Okay. So we got central tendency, like formulas like mean, median, mode, and interquartile range. All right. And as far as measures of dispersion is concerned, we got range and standard deviation. Okay. So again, it's for those people, those who are just starting with this ML and are not sure about like how to go with these terms or are not clear with these terms, especially. And I have seen people like even they know a lot of maths and they have done even graduation to math, they are not clear with these small concepts. Okay, so with simple example, I will try to make sure that you understand and get these terms. Okay, so for example, I'm just going with a small data set that you have. Okay, I've taken a small data set here, 0 2 3 2 1 0 0 2 0, for example. That's my data. Okay, so how to find the mean of it? Mean is simply the average, right? So what you will be doing is you will find the sum of all the elements that you have divided by number of elements, basically, right? So After doing that, 0 plus 2 plus 3 plus 2 plus 1 plus 0 plus 0 plus 2 plus 0 divided by number of elements, you'll be getting the mean value as 1.11. Is that clear? Now, the second thing is how to find median. The median is you will arrange it into ascending order. All right. So after converting this into ascending order, you will have 0, 0, 0, 0, 2, 2, 1, 1, 2, 2, 3, right? And the middle number that you have is 1. Okay. After sorting it into ascending order, whatever middle value that you got, that will be the median. Is that clear? And now the third one is mod. So mod is basically into your data, which number is repeated for the most number of time. So for here, for example, in this, you can see 0 is repeated 4 times. Is that clear? So for this, mode is what? 0. If you have, like, for example, 2 10 times, so you will be having mode as 2, basically. I hope you got these 3 important, mathematical terms that we quite use into machine learning and data science. Okay, mean, median, and mod, basically. Okay, then there's something called interquartile range. So from this diagram, I will make you, I will explain you about interquartile range. Before that, what is range? Range is simply means minimum value to the maximum value. That is your range. The minimum value that you have and the maximum value that you have, that becomes your range, basically. So now understand the meaning of interquartile range. You will separate your data, or you will sort your data, and the point in between will be what? The median, basically, right? So from median point, 25% on the right hand side, 25% on the left hand side, you have to divide. So this is called as Q1 or quartile 1, and this is known as what? Quartile 2, basically. So from median, 25% on both the side will have this quartile, and this range, this 50% range, 25% on both the side of median, is called as interquartile range. It's very useful, especially in box plot. We'll see the importance of it, and even into data set, just to check whether the outliers are available or not, we will use this. So I hope every one of you got the meaning of interquartile range. So now the next 2 important terminologies that we have is variance and standard deviation. Okay, they both are used to check the dispersion of your data, how your data is distributed or dispersed. So what is variance? Variance is average of squared differences from the mean. Okay, I have one example of it as well. I'll be just showing you. And standard deviation is square root of your variance. It's as simple as that, guys. So we might have heard about standard deviation is denoted by sigma. It seems to be a rocket science, right? It seems to be very difficult to understand what is the meaning of standard. Some simple example. Let me just explain you. Okay. For example, if I have this data set, I hope you can see this 14548. This is a data set that I have. First, I have to find the mean of it. Okay, 4.5 or 4.4, and find the differences from the mean of all these points that you have taken. Okay, that's what I have found. And then what you have to do is you have to square those values. Now into machine learning and into stats, you will encounter this lot of time that you will square values. You will square values. The reason of squaring is you don't want a negative term. Okay, you can see it here after okay, so there will be at least there will be values, negative values as well as positive values, but you don't want negative values, right? You want only positive values while comparing the distances, basically. So that's the reason there are 2 things that you can go with. You can square them, or you can simply take magnitude of it, right? But your variance, go with squaring of the values. The good thing about squaring is whatever value you have, that will be amplified. Okay, and in some of the statistical formulas, we require to amplify things, right? So that's the best thing. The best thing for this is to go with what? Squaring, basically, instead of going with magnitude. Okay, so then find the squared differences and its average. So this is the squared differences. I just have squared all the values, and then I have divided by the number of elements. That's how you find mean or the average. So I got 5.04 to be the value of variance. It's as simple as that, guys. That's how you calculate variance of even of the whole column. If you got, like, for example, 10,000 rows, even for 10,000, your computer will be doing the same process. I've just taken a small example to explain you guys, right? So whenever you say ask your function to perform or just to find variance or standard deviation, it will be doing all these process on the complete column. Okay, we'll see those libraries as well. Just wait for some time. Right now I'm explaining you all the possible concepts that are there. Now, I hope you got the meaning of variance. Now, you just have to do square root of variance. From that, you'll be getting what? Standard deviation. So I hope you got how to get a standard deviation. Again, I'm repeating, from the data set, the first thing you have to do is find the mean value. And from the mean value, you have to find the differences of all the points and the mean value. Okay, you will be getting those differences, and then you have to square all those differences because to avoid this negative value, and then you have to divide it by number of elements. You got number of elements to be 5, and there you are getting 5.04 to be the value of variance. And from variance, you just have to do what? Square root. And from getting like square root, if you do, that will become what? Standard deviation, and it is denoted by sigma. Okay, it's denoted by the symbol sigma, basically. Okay, and there are two more. Okay, two more statistical formulas: covariance and correlation. Again, they are very simple, and I will make sure that you understand these terminologies as well. So the formula of covariance is summation of xi minus x dash multiplied by y dash, yi minus y dash divided by n. So whenever you see sigma, again, those who are not much familiar with maths, we as soon as we encounter sigma or pi, we get goosebumps, right? We are not really comfortable with those symbols. Guys, it is simply addition. When you have sigma, it simply means whatever terms that you're using inside it, for every term, you just have to find sum. That's it. And if you're going with pi, it simply means you are multiplying it. Okay. So don't hesitate of using the sigma or to understand the sigma. Now, understand the meaning of covariance. Now, covariance is about any two entity you're talking about. Let me go with one entity to be x and other entity to be y. So we have to find for each value of x, how it is away from, or what difference it has from its mean value. Okay, whatever is the mean value of your x that you have taken, you have to find the value of this multiplied by yi minus y dash. Again, how your y is different from your mean value of y, and divided by the total number of samples that you have, or total number of value, or total number of rows you have. Okay. So now what is the significance of covariance? Covariance will be just giving you, like, while your x is changing, when your x is changing, at the same time, how your y is also changing. Okay. So if you want to know about two persons, your covariance is best for you. Okay. Or in terms of machine learning, if I say, if you want to know how two things are changing according to each other, you will be going with what? Covariance. Again, the value of covariance will be large. We need to bring it down to -1 to +1. So for that, we have something called correlation. We take covariance as it is, then we divide it by the standard deviation of x and the standard deviation of y. So covariance divided by standard deviation of x multiplied by standard deviation of y will give you correlation. Is it anything now difficult for you to understand what's the meaning of correlation? So if I'm finding correlation of any two features, what is the meaning of it? I am just checking that how those two things are correlated to each other, or one, like the way one is changing, how other is changing with respect to it. It's as simple as that. I hope every one of you got the meaning of covariance and correlation as well now. Okay, cool. So now moving ahead. So that was all about statistics part, guys. That is enough as far as summary statistics is concerned. Okay. Now I will be moving ahead, and I will be exploring Python libraries. That was, I guess, enough of theory part, I would say. But I hope you got the lot of jargons of stats that we generally use, and we don't understand those jargons, right? Mean, mode, median, correlation, covariance. So these terms are not really easy to understand, but I hope with these simple example, you got all the terminologies of summary statistics that we use as far as your EDA process is concerned. Okay, so now let's explore Python libraries, and I'll be going with with some one simple example to do that, and three libraries I will be exploring: pandas, and then matplotlib and seaborn. Okay, there are a lot of methods into it. I have selected the best one because we don't have enough time. It will take around 5-6 hours to explain, each and every library in detail. So I have selected the best methods of it just to make you understand the concept of EDA basically. Let me share the screen again. Just a minute. All right. So is it visible? Let me share the screen again, guys. Is my screen visible to all now? All right.
Yes, sir.
Yes, sir.
Okay, cool. So as I said, I'll be going with 3 libraries that we generally use. One is matplotlib.pyplot, and I hope you know Python. All right. So that's how you import your libraries in Python. And I will import this as PLT. And second, as I said, seaborn. So these two are there for visualization purpose. All right. And then we got a third one called pandas. Very important. We will use it everywhere into your machine learning and AI. As far as your Python is concerned. Now, the next thing is, let me tell you first thing for new users, especially those who are not familiar with even Python. I am using Collab. It's of Google, and it's like very nice platform where you can code in Python or any other language as well, and you can just simply execute like your code and see the output here as well. It's online. Online, you can simply go into your drive as well, and from drive you can see new file, and into file you have one option called collaboratory. Basically, that's Collab file, and this will look something like this. You can rename it. All right, and you don't have to import or install these libraries. They are all installed already. Okay, you will be getting it directly online basically. So I have taken these libraries, and always remember, if you want to explore or understand any concept, if you come to know a new concept and you just want to apply, for that you need a data set, for example. So you won't be going to Google and searching for data set there, right? So the best thing for us is Python has provided us with inbuilt data set. That are very nice data set, right? Like clean data set. But as far as being a data scientist is concerned, you won't be getting a clean data set. You have to do a lot of pre-processing and EDA process on that. But as far as explanation of these concepts are clear, is concerned, that is the reason I'm going with a clean data set, which is already available with us into sklearn library. Okay, so there's a library called sklearn.datasets. Let me just explore it for you. sklearn.dataset. So you can go on its official site and see all the data set that we have. Like we got Boston diabetes, digits, wine, breast cancer, and Boston house price. One of them is Aegis data set. Okay, one of this Aegis data set. I'll be using this Aegis data set. So again, let me just give you a brief about this Aegis data set. So it was, after like one person have collected this data set of Aegis plant, basically. Okay. So into Aegis, we have this is something called sepal, and this to be petal. All right. And there are 4 types of, iris plant, basically. Iris versicolor and iris setosa and iris virginica, sorry, 3 types. So based on the size of petal and sepal, we will classify whether it belongs to versicolor, setosa, or virginica plant. Okay, this is the data set that I have. So I'm going here and I'm just showing you like how to import a data set. So import sklearn.data sets, and I have imported that to be DT. And from this, let me just show you those who are new to this Collab. So what you have to do is, from this data set, which I have imported as DT, I want the data set basically, right? So let me just press Control Space. Okay, so all possible, modules or the classes that I can import from DT will be listed out here. I want to go with Iris. So for Iris, there is something this called as DT dot load Iris. Basically, is that clear? So you have to go with this, and you have to put the round brackets with it. So now this load Iris data set will be having a lot of things into it. I mean, it will be just like a zip file basically. So from that, you need to have X and Y separated into it, right? So I'll be having X equals to pd.data frame, and I'm just getting the iris.data into my X, right? And Y, that is my target final value I will be taking into Y. And from this, I'll be just exploring X, and I'll be just checking the X. Let me just explore Y for you. So can you see this? I got 0, 1, and 2. As I said, it's clean data. It's already labeled data. So we got 3 different values of Y. One of them will be like 3 of them will be what types of your iris plant, basically, right? And let's explore X now. Now, guys, I'm going with pandas library. Okay. So in pandas, there are a lot of functions, methods available. I'm just exploring them one by one. There is something called head that will use quite often as soon as you import your data set. Your head will be giving you information or first 5 you can say rows from your data set. First 5. Okay, so this will be like enough for us to understand like what type of data I have into my data set. Okay, so as far as this data set is concerned, just to make you understand, guys, I'm just going with a simple data set, and I'll explain the whole thing with other data set as well. Okay, so x.head, as I said, you can simply see how many columns are there. Total 4 columns starting from 0 to 3. Okay, the name of those columns are 0, 1, 2, 3, and first 5 rows will be displayed to you. So that is like enough for you to understand the type of data that you have. So you can see I have all continuous data here. All the data that I have into all the columns is what the can say continuous data. Okay, and if you want to know the last 5 terms, you will be going with x.tel to be the function you'll be using. Okay, last you can simply say 5 will be displayed to you. So it is from 0 to 149. You can say total 150 number of rows you have into your this Aries data set basically. Okay, so let me just write it here to be head first 5 values, and you can increase the value as well. You can simply put 10 here, so it will display 10. Likewise, you can go with. So, but basically we go with x.head, and that should be enough for you to just explore the data and just to see what type of data you have. Now, apart from that, there's something called info as well. Okay, so x.info will be now telling you a lot of things. Now just see it. What we have this to be the column names. Okay, these are what my column name, and here I am getting not or non-null count. Okay, so from all the values that you have, if you have any missing value, that value into pandas is called as a null value. Okay, and you won't be having that to be a missing value, and it won't be even considered as space or 0. It will be considered as not null. You can say null values basically. Okay, now non-null count is the meaning of it. How many values from 150 values are not null values? Okay, if you have out of 0 to 149, clearly says that total 150 values are there. Into first column, for example, if there are two values which are null values, okay, means the data is not present for them. So here the count will be 148 non-null values, right? And from this you can simply understand how many null values you have, two null values. And apart from that, very important thing that we have is what type of data we have into each column. So here in this case, we got all float 64 type of data. Okay, so your info, I hope you got, it will be giving you about range index from where it is starting and where it is going and how many total number of columns you have. All right, so that you will get from X info. Now the important one is something called describe. Okay, describe. It's a function called describe. Now it is giving us a lot of information which we'll be using for pre-processing and even for selection of your algorithm. So what is the first one? Tell me. The count. Okay, total values which are available. Total, again, non-null values which are available for each column. We're getting those values here. And then we got something called mean value, right? So what is the mean value? What is mean value? Average value from that column. It has already like calculated for you. I told you standard deviation. Study stands for what? Standard deviation. So standard deviation of each column is calculated by the describe. You don't have to worry about of the calculation ways. But when you see this study, you should be able to get what is the meaning of it. So what in background it has done? It has got the values of variance, right? All the calculation it has done, what we have seen with a small data set, we have seen it, right? So those calculation it has done, and from those values, it got the standard deviation for each and every column, guys. So it has done so fast. Can just imagine of 150 data, it has got all the values. Okay. Now you got minimum value, which is present into that column. And now these three are important, which are related to what? Interquartile range, right? 50% is basically your median value. And from 50%, you got 25% this much and 75% this much. We talk about interquartile range, right? So this is your interquartile range, basically. So your data falls into interquartile range, and the value of interquartile range are these, basically. And like minimum value is something like from all the 150 rows, whatever the minimum value you had, you will be having it here. And the maximum value will be here. Is that clear? So describe is an important function for us, right? It's giving a lot of information. And one more thing, the data set that you have here, everything. But what if I have, a column which will have, we can say, a categorical value. In such cases, if you have categorical data, guys, come on. Gender, if you have male, female, you have, will you be in a position to calculate standard deviation? Or is it of any use to calculate the standard deviation, all these things of any categorical data? No, it's of no use, right? And your describe function will leave out, will drop those, and will consider only features which will be having numerical values. I hope every one of you got this. Any doubt as of now? Any doubt you have into this? Please ask me. Okay, now there's something called x dot n unique, again an important one. It will be giving me the unique values that I have into each column. So out of 150 values that I have, into 0th column, I just have 35 unique value. Okay, I mean from 150, how many are unique? 35 are unique. So 35 are divided into total 150. Okay, and into 1 I got 23 unique values. Similarly into 2 I got 43. From 3 you got 22. Okay, even from this you will be in a position to understand which all are categorical database. When you talk about categorical data, like for example gender, there will be female or male, right? So if I have a column of this gender, how many unique value will be there? Like for 150 rows, I will be having only 2 unique values, that is male or female. Likewise, for all categorical, it can go up to 4, 5, 10, not more than that, right? So 35 is a big number. So you won't be having a 35 categories, right? So all these are what you can simply conclude that they are numeric values. Basically, they are not, they are not categorical data. Basically, now the next one is very important again. Is NA. Okay, this will find, or this will return a Boolean value basically, and if there is any, you can say missing, or NA is available. NA simply means what? Not available, or a missing value is available, is there. So it will return true for it. Otherwise, it will return false. So we don't use SNA directly. We ask it to sum it up for us. Okay. So on SNA, we call sum method, and you can simply see this now. On the first column, in first column, there are 0 rows. I mean, 0 values, or 0 simply you can say missing values, right? If you have any missing value, it will be reflected here. Now, guys, tell me, we are exploring it into EDA, right? Tell me, what we will be deciding into pre-processing? If we have very much, out of 150, 140 are missing values. Into EDA process, we are getting that thing, right? That, out of 150, I got total 140 missing values. So in such case, we will be in a position to understand or get that it is better to drop that particular column, because there are a lot of like majority of the values that are what? Missing values. And now, for example, I have a column where you got very few missing values. Like, for example, I have a column called age, and there are only few missing values. Like, out of 150, I got 10 missing values. I can't leave out those like 10 values space, because if you're just leaving it out, that might be considered 0. That can have very bad result, right? So one thing you can do is you can simply delete those 5 rows. All right. These are the things that you will decide after saying this. That's what I want you to understand. Or you can simply replace those 5 values with mean value of age, or mode value of age, mod value of age, or you can median value of age, or anything that you're comfortable with. We will be doing that into pre-processing. EDA is simply to explore your data, right? And you are just exploring your data in terms of describe, or just checking how mean, median values are, how your data looks like. And from this function, you're getting, or you're just trying to get how many null values are present into your data set. So far, so good. Understood everything, guys. Now, there's one more thing called correlation. I told you we can find correlation. So there is formula into pandas that will give us correlation directly. So the formula is core. Simply check out. You can call this function, and it will find correlation of all column with all other columns. Okay, now for example, I got how many columns here? I got 4 columns. So correlation of 0 with 1, 1 with 2, 2 with 3. Likewise, for all, it will calculate 4 by 4 matrix. Is that clear? If you just print the value of core, you can see it to be like this. Just print it. So these are the values of correlation. Now, coming to the values of correlation, I told you one thing. If they are highly correlated, like, what's the meaning of it? If I talk about X and Y, if X is changing in similar way, exactly similar way, Y is also changing. So they will be called as what? They are highly correlated. And if X is changing and just opposite of it, Y is changing, we will again say it to be highly correlated, but into what? Negative terms. So correlation value will be in between -1 to +1. In simple term, you can say if you're getting a -1, they are inversely proportional, right? If you're getting 1, they are like directly proportional to each other. And you will be having values in between as well, right? So of course, if you just talk about 0, 0, you'll be getting all 1, 1, 1, right? 0, 0, a diagonal element, you'll be getting 1, 1, 1. And here you can see 0.8, again, highly correlated. So 0, 2 is highly correlated. So now, guys, you got the correlation value. What purpose we will be using it for? If 2 columns are highly correlated, what's the meaning of it? if they are highly correlated, it simply means that the way your x1, for example, x1, x2 are highly correlated. The way x1 is like influencing y, x2 will be influencing y in the similar way. Do you agree? Because they are highly correlated. So in such cases, as they are highly correlated, we will drop either x1 or x2. Is that clear? For that purpose, we'll be using what? Correlation. Okay. Now, I'm coming to now that was all enough for as far as summary statistics is concerned. Now I will just show you how your Seaborn and your matplotlib is we will be using. So let's start with correlation. So there is something called heat map. Okay, that is there into Seaborn. I will be using it. So I have imported Seaborn as SNS, guys. I'm just going with that. SNS dot. There's something called heat map, and I'll just putting this value into it. So it will be giving me this, guys. Okay, and let me just write a not equals to true. So it will be giving me the exact values. Okay, so you can simply see it now. 0 with 0 is highly correlated. Okay, we can use different color combination. There are a lot of things to heat map as well, guys. I'm not going into detail. We already are late now. So if they are very less correlated, you can say we are getting the value to be 0. The very dark. I can simply say that, the column 0 and 3 are very highly correlated. 0.82 you got, 0.87 you got. So from seeing this, you will decide which columns to keep and which column to delete. And this again comes under EDA process. I hope you got it. Now, apart from that, there are many things to available with your SNS. So I'll be just showing you that as well. I hope you got the meaning of heat map, right? So heat map we'll be using for correlation purpose, and there you will see all the correlation values. Okay, then there's something called joint plot. You just use joint plot. So you need to give two values to it, x and y. Okay, and from where you're taking, let me just take it to be from x. Show you what joint plot is doing. It's capital X, so let me take capital X here. Okay, guys, so see it here. What I have done, I have given it two values, that is column 0 and column 1. So you have to specify it into joint plot. And you said take these values of x and y from the data x. So it will be going to data frame x and we'll be taking 0 and 1 from it. And you can simply say it has drawn 0 versus 1. It has plotted all the values of it. And from this, you can simply get this, okay? I mean, you having data of between 5.5 to 6.5, the highest data for the column 0. And similarly for 1, you're having the data which are highest between 3.3 to 2.5. Is that clear? And if you want to get the regression line here, so you can write kind equals to reg. It will be even drawing a regression line for you. You have to put that into single quote. Sorry for it. So it will draw the regression line as well as, and will show you which type of curve your data is making. So that's how you will be using joint plot. Okay. Then there is something called pair plot as well, guys. So it will be giving you detail of all the available values that you have into your data set. It will take time. So pair, and the name of it is pair plot basically. Take some time to print. Yeah, you can say 0, 1, 2, 3. These are the total number of columns are available with you, right? So it will draw the density or clusters of each column with other column. It will simply plot those values. You can see from this you will come to know how your data is distributed. And those who know machine learning, those who have done it, the algorithms of it, based on the type of density we decide on the algorithms as well, right? If you're going for if you're going with unsupervised learning algorithm, so if your data is scattered, you won't be going with DB scan, such cases, right? Similarly, for classification and regression algorithms also, you'll be deciding upon based on seeing all these things. Is that clear? So that's how you do pair plot, guys. And there is something called box plot as well, which is there into, I'm going with, matplotlib class. So I've imported it as plt dot something called box plot. Just show you with one value of x. Okay, so you can see it here. It has drawn box plot for your x of 0 column. So understand the meaning of box plot. This is the minimum value that you have into that column, and this is the maximum value that you have into that. And the middle part, you might have seen this into share market, guys. Like you have candlestick, right? So candlesticks based on this only. Okay, and the interquartile range is in between this. We have seen interquartile range, right? So this will be 25%. This will be median value here. Okay, the value you can simply see. This is median value, and this is what the 75% quartile basically. Is that clear? So again, this is very important for us to go with box plot. If you have any data outside this, guys, so that will be considered as outlier, and detecting outlier and and removing that outlier is an important step in pre-processing. So we will be getting that using our box plot. Is that clear? So I got one more data set, guys. That is Titanic data set I have already implemented. I just want you to see it. We already running out of time. I told you this EDA process is not really, small process that will take around 2-3 hours to explain in detail. And you need to know machine learning algorithms as well. But as I said, the idea of this webinar, from my side was to make you comfortable with machine learning and make you understand few of the concept of summary statistics and of this visualization. So I hope I have done that. I'm just showing you this Titanic data set that I have taken from Kaggle, guys. And there is one more function to data frame called shape. It will be giving you number of rows and number of columns available. So I got 891 rows and number of columns to be 12. Okay, we use it into EDA process again. And we know about head. Head is just to see what type of data we have. So it will be listing out all the columns and first 5 rows of that column basically. And as I told you, we'll be just checking out for number of null values. So from this you can simply see age got 177 missing values out of how much? 891 rows we have. So it's a huge number. We need to replace it. So we'll understand from this. And there is something called cabin, which got 687 missing values from 891. There's a huge value, right? Huge difference. I mean, like huge value of cabin is missing. So we can simply decide that cabin has to be dropped. Okay, and describe, you can see now the data that I have, like name, sex, and ticket, cabin, and embarked as what? Categorical data. All right, and survived or not, that is again a categorical data, right? 0, 1, that is like already label encoded for you. So from this describe, you will only see those values which will have numeric values. Okay, the column which are having categorical data won't be displayed here. And as we have seen about NUnique, so from NUnique, as I said, survived got only 2 values. From this you can decide that survive is basically what a categorical. P class is having 3. It's again a categorical. Sex is having 2, male and females. It's again a word. It's type of category. And embark again 3. So you can decide it to be what type of category. Is that clear? And one more thing, guys. If you just want to see into any of the column, how many unique values are there? So instead of n unique, you just have to go with like df dot the name of your column dot unique. You have to. And it will list out all the values which are unique, or the unique values of that particular column. And let me just show you for this as well, the correlation table. You can see this correlation table is built, and from this you can simply list out which are there, which are not really correlated from these values basically. And there's one more, guys, something called cbond.displot. Okay, it will distribute and show you column versus conclude that there are more than 80 people which comes under the age of 30. So from this, you can even understand how your data is kept. Okay. And to this same thing, we have something called hist plot as well, histogram plot, which is similar to this plot is shown. There are a lot of parameters are available to it. I'm not going into detail of parameters. You can just later on you can just check it out. Okay, and then I told you about pair plot as well. So pair plot will be plotting each and every column, and from which you can simply explore the data. And now there's something which was not into your Aegis data set, that is how to check the categorical data. Okay, so there is something called count plot. Into categorical data, like you have sex to be categorical data, where you will be having male or female, basically, right? So you just want to check how many males and how many females are there. Out of, you got around 900 data, right? Out of 900, how many males and how many females are there? So I'm doing that. SNS.count plot is there to count, and it will be accepting one categorical. I have given survive, which is also a categorical data set. You can simply say 0 and 1. So 0 is like people those who didn't survive into Titanic crash, and there were around 300 people those who survived. So now this will be important for you to see, guys, because you have to do undersampling and oversampling once your data or the y value is very much different. Okay, so to decide that also you will perform this operation into EDA, and from this you will be deciding, like after doing all the EDA, you will be deciding like what you have to do into pre-processing, what columns you have to delete, like what values you have to put into the missing values, and how your data actually looked like, and finally which algorithm you will be selecting. I hope I have done. Any question from anyone? That was all. Like I would say to be the introduction to EDA, guys. There are a lot of things you might have heard that even data scientists, when they like they perform their job, they spend around 60% of their weight of the time on pre-processing mode, doing EDA and pre-processing mode. So cleaning of your data is something really important, and I would say I just have given you like 10% of EDA. Right. So there are a lot of methods available which you can explore it. But these were something, you always will be doing no matter how you got the data. So that's enough from my side. Any question from anyone? Any doubt you have, or you didn't understand anything? You can just put into the chat box as well.
Participants, do we have any questions?
I hope you are not exhausted. Come on, guys. I explain you in the best or simplest way possible, right? So you got everything about summary statistics as well as visualization. So is it something like that you understood everything? No doubts coming, or it's other way around?
Yes, sir, we understood.
Okay, good. I'm still expecting. I'll be waiting for a few time. If you have any question, you can ask me. Anyone who's monitoring YouTube, so can ask, can see, and if there is any question, I will be answering that question. No questions? Okay, so I guess Nida ma'am, we're fine to end this session.
Yes, sir. So that there are no questions on YouTube as well. I just checked.
Okay,
So
okay.
thank you for a wonderful session and giving us a brief introduction of what EDA is all about, into especially this world of big data where data is everywhere. So I hope you had a good session, participants, and I hope to see you all more for such sessions. Thank you, sir, for your time.
Thank you.
And thank you everybody from Aegis. Thank you.
Thank you, everyone.